Hey everyone, welcome to this explainer on the gradient of a straight line. We're diving right into a complete revision of KSSM Form 2 Chapter 10 Mathematics today. Now, I know gradient might sound like just another dry math term you've got to memorize for a test, but it's actually a super fascinating tool that helps us measure the physical world. By the time we wrap this up, you're going to see lines not just as ink on a page, but as actual structures with real physical properties.
Here is our roadmap for today. We'll start by decoding the gradient, then look at two essential math formulas, explore steepness and slope direction, check out zero and undefined lines, apply this to a real-life scenario with Jamali, and wrap up with some summary and revision tips.
All right, Part 1, Decoding the Gradient, Understanding the Basics.
So, what actually is a gradient? Honestly, it's just a simple ratio. It is literally just the ratio of the vertical distance to the horizontal distance. That's it. You're basically just comparing how far up you go versus how far across you go.
Let's put that into practice and look at these two lines. For line PQ, you can see our vertical distance is 4 units and our horizontal distance is 3 units, so our gradient ratio is simply 4/3. Now take a look at line BC. Here, the vertical distance is 2 units and the horizontal is 3, making the gradients 2/3. See? You just plug in the vertical and horizontal units, and boom, the math gives you the exact gradient fractions. No guesswork at all.
Moving on to Part 2, Two Essential Math Formulas, your calculation toolkit. Now, I know formulas can look intimidating, but think of these more like handy tools in a toolkit. You just grab the one you need depending on the specific job you're facing. On the top, we've got the coordinate formula, y2 minus y1 all over x2 minus x1. You'll want to use this one when you're dealing with two specific coordinate points on a Cartesian plane. But down on the bottom, we have the intercept formula, which is negative y-intercept over x-intercept. And this is your go-to tool when you know exactly where the straight line crosses the x and y axes.
Let's actually put that coordinate formula to work. Step 1, we identify our 2 points. Let's say point A is 3, 1, and point B is 6, 7. Step 2, we just drop those numbers right into our formula. The y values go on top, so that gives us 7 minus 1. The x values go on the bottom, giving us 6 minus 3. Step 3, do the math. 7 minus 1 is 6, and 6 minus 3 is 3. Divide 6 by 3, and we get a super clean gradient of 2. Easy, right?
Okay, let's grab that other tool and try out the intercept formula. Step 1, find your intercepts. Here, our y-intercept is 8, and our x-intercept is negative 5. Step 2, substitute them into the formula. But wait, you've really got to be careful here because the formula already has a negative sign built into it. So it becomes negative 8 over negative 5. Step 3, calculate. Those double negatives completely cancel each other out, leaving us with a nice positive gradient of 8 over 5.
Next up, Part 3, Steepness and Slope Direction, the Personalities of Lines.
All right, here is an absolutely crucial rule to remember. The greater the absolute value of the gradient, the steeper the straight line. Imagine you're out for a hike, right? A line with a gradient of 4 is going to be a much steeper climb than a line with a gradient of 2. Basically, a higher number just translates to a steeper, way more exhausting hike. Now, let's see how this ties into the direction of the slope itself. We've got positive gradients and negative gradients. A positive gradient means the line is going up or inclining to the right, like lines I, J, or MN here. Think of that as climbing up that steep hill. On the flip side, a negative gradient means the line is going down, inclining to the left, like lines EF, GH, or KL. That's kind of like sliding back down the other side of the hill.
Looking at a few specific examples, you can really see this in action. Line MN actually has the highest gradient because it's the most vertically inclined. I mean, it shoots almost straight up. But then look at line QJ. It has the smallest gradient because it's the most horizontally inclined. It's almost completely flat. So, the takeaway here is that vertical inclination gives you the highest numbers, while horizontal inclination gives you the lowest.
Part 4, Zero and Undefined Lines, the Extreme Edge Cases.
So we really need to understand these two extreme edge cases. First, a zero gradient. This is a line perfectly parallel to the x-axis, like line AB. Think of this as just walking down a totally flat hallway, zero effort, zero slope. But then you have an undefined gradient. That's a line perfectly parallel to the y-axis, like line PQ. Imagine trying to walk straight up a vertical brick wall. You can't do it.
The vertical distance is there, sure, but the horizontal distance is 0. And since we all know you can never ever divide by 0 in math, the gradient is just completely undefined.
Moving right along to Part 5, Real-Life Application, Jamali's Journey.
Let's bring this into the real world. Every day, Jamali fetches water from the river and heads into the forest. First, he walks from his house up to the forest. The vertical distance is 30 and the horizontal is 10. So 30 divided by 10 gives us a gradient of 3. That is a pretty solid steep climb. But later on, he walks from the riverbank back to his house. This time, the vertical distance is 20 and the horizontal distance is 40. 20 over 40 simplifies down to a gradient of 1/2. So what does that mean? It means his walk from the river is a much flatter, way easier stroll compared to that brutal trip up to the forest.
And finally, Part 6, Summary and Revision Tips, tying it all together.
Okay, let's quickly review our Ultimate Form 2 Chapter 10 concept map so this all sticks. First, the definition. Gradient is simply the ratio of vertical distance to horizontal distance. Second, remember your two tools, the coordinate formula and the intercept formula. Third, check your direction. Up and to the right is positive, down and to the left is negative. Fourth, watch out for those special lines. Parallel to the x-axis is 0 and parallel to the y-axis is undefined. And lastly, the steepness rule. The greater the absolute value, the steeper your line is going to be.
I want to leave you with a quick thought experiment. Look around you right now. Seriously, where do you see positive, negative, or 0 gradients in your own daily life? Maybe it's the steep pitch of your roof, the stairs you walk up every morning, or even just the perfectly flat floor you're resting your feet on right now. You see, math isn't just trapped on a page or stuck inside a textbook. It literally shapes the world around us. Thanks for joining me for this explainer, and hey, keep an eye out for those gradients out in the wild.